In this video, we are going to continue our work on solving systems of equations using the method of elimination. Now, remember we said when we do substitution, you want one of your variables to have a coefficient of 1, and that's the one you're going to choose to solve for. But sometimes you have a situation like this where none of the coefficients are 1, and that's a good time to use elimination. For the method of elimination, I want two of my coefficients to be opposites of one another. You can see here I have positive 2 and negative 2. They're opposites. So what I'm going to choose to do is add my equations. And I'm just going to add straight down. When I do that, the negative 2y and the positive 2y that are opposites are going to cancel one another out. And they're gone. They're eliminated. That's why this is called the method of elimination. So when I combine my x's, 9x and negative 5x, that makes 4x. And negative 1 plus 13, that makes 12. Dividing both sides by 4 to get x by itself. And I end up with x equals 3. Okay, now if you remember from when we did the substitution method, just getting one variable is not sufficient. In my original equation, I have both x's and y's. So when I get my answer, I want it to be the point x comma y. All right, so let's look at getting the y value. So I have x, and I can choose to substitute it into the second equation, or I can choose to substitute it into the first equation. It really doesn't matter. Neither one of them is easier than the other, so I'm just going to choose the first one. All right, I'm going to substitute I'm going to substitute 3 in place of x. I'm going to simplify. My goal now is to get y by itself. So I'll subtract 27 from both sides. Don't forget to bring down that negative with the 2. Dividing both sides by negative 2 to get y by itself. And I get the answer y equals 14. And then I'm going to write my final answer as the point 3, 14. So if we wanted to check this one in our calculator, remember to type it in the calculator. We need to get y by itself on both of those. So I went ahead and did that to save us some time. And I got y equals 9/2 x plus 1/2. That's what we would put in y1. And then y equals 5/2 x plus 13/2. That's what I'm going to put in y2. Unfortunately, today my calculator is not working properly, so I'm going to do that in Desmos. And you can see that I've typed them both in just like I would have if this had been my calculator. And I've put the fractions in parentheses so that I don't have any order of operations difficulties. And what I have is this. So the red line is my top line, the blue line is my bottom line, and they are crossing somewhere off my screen. I'm not sure where. So if I wanted to do this in my calculator, what I would need to change is the y max value. And I don't really know what it is going to be, but I hope it's going to be somewhere above 14 because that's the answer that I got. So I'm going to try 15. And there it is. There's my point of intersection. It's the point 3, 14, which is exactly what we got when we solved it. So again, just like before, you can choose to check these in your calculator. Graphing is a great method for using, but please remember when you take your test, you're going to have to show me work on how you can solve this using elimination. So make sure you're able to do that. Okay, let's go back into the notes. And let's do this one. 2x plus 9y equals negative 1. And then look at the bottom line. I have negative 8x, which is not the opposite of 2x, and negative 18y, which is not the opposite of 9y. So I don't have the opposite of either one. I have to create an opposite. Well, I could multiply the top one by 4. 2 times 4 is 8. And then my x's will eliminate. Or I could multiply the top one by 2. 2 times 9 is 18. And then my y's will eliminate. The truth is, it doesn't matter which one you do. You can eliminate either the first or the second variable, and it works out to be the same. So I'm going to choose to eliminate y on this one. I'm choosing to eliminate x on this one because we eliminated y on the last one. So I'll multiply this by 4, and I'm going to have to distribute the 4 across this whole equation. So I will get 8x plus 36y equals negative 4. And just like before, I'm going to add straight down. And my x's are opposite one another, so they're going to cancel out. Negative 18y and 36y makes 18y. And negative 4 and negative 14 make negative 18. All right, I'll divide by 18 to get y by itself. And I get y equals negative 1. So at this point, have we completed the problem? No, because remember what we're finding is a point of intersection, and I don't have that point unless I have both the x-coordinate and the y-coordinate. So I will substitute y, and I can substitute into either one of those equations up there. This time I'll do the second one, because I did the first one last time. Putting that negative 1 in place of y. All right, let's see if we can solve for x. So negative 18 times negative 1 is positive 18. Oops, I forgot to write my x. Negative 14 over here still. Subtracting 18 from both sides. Negative 8x equals negative 32. Divide by negative 8 to get x by itself. And x equals positive 4. So my final answer written as the point of intersection is the point 4, negative 1. I'm not going to choose to put this one in the calculator, but if I did, my two equations should cross at the point 4, negative 1. Okay, let's try this one. So just like before, none of them match, right? Negative 7, negative 4 are not opposites. Negative 5, negative 3 are not opposites. Last time I only had to multiply one equation because I had a coefficient that was a multiple of another one. But this time I don't. Negative 4 and 7 are not multiples of each other, nor are negative 5 and negative 3. So I'm going to have to multiply both equations. And remember, I want my numbers to be opposites. So let's suppose this time I want to cancel out the y's. Well, what will 5 and 3 both go into? They'll both go into 15. So I need one of these to be a positive 15, and I need one of these to be a negative 15. So I'm going to choose to multiply the top equation by negative 3, and I'm going to choose to multiply the bottom equation by positive 5. So when I chose negative 3 on top, remember when I distribute that negative, it's going to change the signs on everything. So they're all going to end up to be positive. However, in the second line, when I distribute that positive 5, it doesn't change any signs. And so I end up with opposites right here on y. Positive 15 and negative 15 are opposites. So when I add straight down, those are going to cancel out. All right, 12 and negative 35, if I put those together, I get negative 23. And 6 and 40 make 46. Dividing by negative 23 on both sides, x equals negative 2. Okay, now remember what I'm trying to do. At the end, I want to have the point of intersection. I want to have the point x comma y. So I'm not done yet. I still need to find y. So I've got x. Does it matter if I choose the top equation or the bottom equation to find y? Nope, it doesn't matter at all. And just like before, neither one of them is easier. So I'll choose the top one this time. Negative 4 and negative 2 multiply together to be positive 8. Subtracting 8 from both sides. We got negative 10. Dividing by negative 5, and I'm out of space down there, so I'll move over here. Y equals 2. So my final answer written as a point is the point negative 2, 2. So if I graphed these, they would cross at the point negative 2, 2. And also, do you remember how we said you could check these algebraically? If you were not going to check them on your calculator, you're going to check them using algebra. You would need to check in both equations. Substitute in negative 2 and positive 2 in both equations to make sure that they both turn out to be correct. And if both of them turn out to be true, then you'll know your answer is correct. All right, let's try this one. So this one is different again. Neither one of them are opposites, 3 and 5, negative 2 and negative 5, but also this time they're not lined up. So I'm going to have to do two things. The first thing I'm going to do is I'm going to add this 2x to both sides. Kind of write it real small right there. And when I do that, I'm going to get 2x plus 3y equals -1. The elimination is really difficult if they're not lined up. All right, well, this time I'm going to choose to eliminate the x's because the signs are already opposite one another, and I'm not going to have to worry about distributing a negative. Okay, what will 5 and 2 both go into? Well, 5 and 2 will both go into 10. So to make the top one a -10, I'm going to multiply by 2. To make the bottom one a +10, I'm going to multiply by 5. So when I get that -2 in the top equation, and I'm sorry, not -2, -10, and I get +10 in the bottom equation, they're opposites of one another. And so when I add straight down, those will cancel out. Remember, I want two numbers that are opposites of one another in order to cancel those out. So let's keep adding straight down, dividing both sides by 25. I get y equals 1. Okay, now what should I do once I get to the point of saying that y equals 1? All right, I want to substitute back in. Does it matter which one? Not at all. So this time I'll choose the bottom one because I did the top one last time. All right, and I'm going to work now to get x by itself. So subtract 5 from both sides. And divide both sides by -5 to get x equals -2. All right, so what I have found is the point of intersection of these two curves. So I'm going to write my final answer as a point, -2, 1. All right, and just like before, if I wanted to check it, I have the choice of either solving for y and substituting both of these into my calculator, or I can choose to substitute -2 and 1 in for x and y in the first equation and the second equation. It's important to check it in both equations. And hopefully it'll work out that both of them will be true and you'll know your answer is correct. If one of them is not true, that tells you made a mistake somewhere and you need to go back and fix it. Or when you put it in your calculator, if they don't cross at the point -2, 1, you'll know you made a mistake somewhere and you can go back and fix that before I grade your test.